and optical fiber. Laser, if you see, that is a light. Optical fiber can be used to communicate using light energy. Both are related to light itself. So we have included both laser as well as optical fiber in physics of photonic devices. Okay. The code is 20PH22. So this is the syllabus, both laser as well as optical fiber. In laser, you have introduction to laser, energy density using Einstein coefficients. This is one of the expected question. Energy density using Einstein coefficients. Condition for laser, requisites of laser, construction and working of semiconductor diode laser. Now itself, I'll be telling you the important concepts. Einstein energy density equation as well as semiconductor laser. These two are most expected questions. Coming to optical fiber, propagation mechanism, angle of acceptance. This is one of the expected question. Derivation of angle of acceptance and numerical aperture. So angle of acceptance as well as numerical aperture. This is one of the derivation. Condition for A propagation, modes of propagation, and types of optical fiber. This is also important. There are three types I'll be explaining later. Normalized frequency parameter, attenuation, optical fiber in point-to-point communication system. That is one of the application of optical fiber. Okay. We'll start with laser now. One second, somebody's. We'll start with laser. Photonic devices, yes, all of you have already answered. Photonic devices are devices for creating, manipulating, and detecting light energy. That means whatever the operation we can do using light energy, those electronic devices comes under photonic devices. One such example is LED, light emitting diode. As the name indicates, LED, light emitting diode. That means it emits the light. It emits the light by using electrical energy. So what this LED will do, it converts from electrical energy to light energy. It converts from electrical energy to light energy. The moment you switch on the bulb, you can see the light. That is a LED. So opposite of that is photodiode. There is there is one experiment related to photodiode in our lab also. Photodiode. That means what it does, it is opposite to LED. It converts from light energy to electrical energy. I'll be asking you the doubts. As soon as I explain a particular concept, I'll be asking the doubt. Please understand carefully. Photodiode, what it does, it converts from light energy to electrical energy. Say, for example, you switch on the bulb, how much light is coming out, I can determine, and in turn, I can convert it to electrical energy by using a photodiode. This is one of the photonic device, LED, photodiode. And also we have laser. Okay, laser is also comes under photonic device itself. What is the acronym of laser? Can anybody? Sangeeta?
Sir?
What is the acronym? Acronym or abbreviation? It is in the Viva question. They'll ask you like this. What is the acronym? It is also called abbreviation of laser. What is the meaning of L? What is A? What is S? What is C? What is R? Sangeeta, I asked you.
Yes, sir.
Just try. If you don't know, it's fine. I'll go to the next. Samprita?
ಕ್ವಶನ್ ಕೇಳ್ತಾಳೆ ಚಿಕ್ಕ
Samprita.
ಇದ್ದಾರೆ
Has left. Oh my god. If you don't know, it's fine. Just try to answer. Don't quit the meeting. Monica? Yeah, who is this? Khalid. Yeah, please try.
Sir,
Khalid.
light.
Yeah, Sangeeta. Yeah, try. Anyone, please.
Light amplification, stimulated emission radiation.
Very good. Very good. Excellent answer. Okay. Mute yourself, all others. So good answer. Laser is nothing but light amplification. L indicates light. E indicates amplification by stimulated emission of radiation. Here, very importantly, you have to note down this SE. So SE is nothing but stimulated emission. SE is nothing but stimulated emission. They may ask you like this: what is the principle of laser? The principle of laser is stimulated emission. Understand now itself. This is one of the expected question in Viva, in lab Viva. What is the acronym of laser? They'll ask you. Then what is the principle of laser? The principle of laser is stimulated emission. Stimulated emission. Okay. So this is that also comes under photonic device. Then we have solar cells, photovoltaic cells. These are related to solar energy, and also optical amplifiers. These are the device can be used to optify the light energy. All this comes under photonic devices. We are not going to study all this. We are going to concentrate majorly on laser. What is laser? Laser is an electro-optical device that produces an intense beam, that is a monochromatic coherent beam of radiation. This laser emits a monochromatic. Monochromatic is nothing but made up of single color, made up of one color. Okay, there will be no more than one color. Okay, let me ask you one more question. Suppose, imagine you have a prism. Okay, imagine you have a prism. Suppose if you pass a monochromatic light from one side of the prism, how many colors you observe at the other end after dispersion?
7, sir.
7 color. Anybody else? I repeat again. You have a prism. You pass a monochromatic light from one end of the prism. How many colors you can observe at the other end? Anybody else here? Abdul?
Only one, sir.
Only one? Is it?
Yes, sir. Because it
Purvaj?
is monochromatic, sir.
Okay, I'll come back to you. I'll come back to you. Purvaj? Yeah, Tejas answered. Vibhaya? Purvaj?
Seven colors.
7. Okay. Punityan? Punityan?
7, sir.
7. Kritika? Only 1. Sneha?
One, sir.
Only 1. Okay. Very good answer. So you can observe only one color. So I repeat the question again. I'm not passing a white color. White color is made up of 7 colors. Vibgaya, violet, indigo, like that. It goes 7 colors. But I'm passing a monochromatic light made up of only one color. Suppose if it is red or green or yellow. Suppose if I pass that and it undergoes dispersion, it gives only one color. If it is monochromatic. If it is white light, yes, I agree with you all. It gives 7 colors. If it is monochromatic, it gives only one color. This is one of the question I'll definitely ask in the lab when you come to the lab. Suppose if you get laser experiment. Okay? Yeah, laser as I've already asked you, acronym of laser is light amplification by stimulated emission of radiation. Look at the word here. See, I've seen in the exam test and all. For style, they'll write laser, Zadia. No, that is completely wrong. The spelling of laser is Laser itself. Should not use Laser. Laser is nothing but light amplification by stimulated emission of radiation. What is the principle of laser? The principle of laser is stimulated emission. It works on the principle of stimulated emission. What exactly a stimulated emission is? In order to understand stimulated emission, we need to understand something called interaction of electromagnetic radiation with the matter. What is electromagnetic radiation? Both electric as well as magnetic fields will be there. When that light falls on a matter, what is a matter? Generally, we can say matter is nothing but anything which has a mass and occupies the space. That is a matter. You can see if you are looking at the mobile, that is a matter. If you are looking at the laptop, that is a matter. Table is a matter. Everything, whatever you can see, that is a matter. The moment you pass some electromagnetic wave to that matter, what is going to happen? We could observe 3 different processes. What are those processes? We'll study now. Okay. Light amplification by stimulated emission of radiation. Also, before we Go to the stimulated emission. These are some general information. Difference between ordinary and laser beam. What is the difference between these two? So this ordinary light, what happens? It is spontaneous. It is stimulated. In both ordinary light as well as laser light, there is an emission. But in ordinary light, light emits spontaneously. Meaning of spontaneous is by itself. By itself. Whereas in the case of laser, what happens? It emits the light with some stimulation. Some stimulation. Suppose if you want to stimulate something or somebody, you have to pass some energy, isn't it? Whereas in the ordinary light, what happens? You don't need any external energy. Whereas in the stimulated emission, you need some external energy in order to emit the light. What exactly is spontaneous, stimulated in detail, we'll study in the next slide. Okay. Whereas ordinary light is non-coherent, whereas laser is coherent. What is the meaning of coherent source? So this coherent source having the same frequency, wavelength, and in the same phase. This coherent source will be having same frequency, same wavelength, and also those two waves will be in phase. Whereas non-coherent, two waves will not be in phase, and also frequency and wavelength will not be same. Whereas in the ordinary light, what happens? It is polychromatic. Poly is nothing but what? Many. Look at here. Look at here. This is ordinary light. It is made up of all the colors. All are continuously arranged. You can't identify it discretely. You can't identify it discretely. Rainbow is the one of the example. Rainbow. It is made up of all the colors. Vibgaya. Whereas laser beam is monochromatic. Look at here. It is only one color. Okay. It is divergent. Divergent is nothing but what? It travels in all the direction. This is one of the example. It travels in all the direction. Whereas ordinary light, the moment you switch on the light in your room, so that spreads to the complete room. It is divergent because of divergent property. Whereas this laser, it is unidirectional. It travels in a single direction. Look at it. This is also one of the example for polychromatic. Okay, these are the differences between ordinary light and to the laser beam. Okay. This is the application of laser. What happens? It can be used, this laser beam with a high energy can be used in drilling. It can be used as a source in the optical fiber. For an optical fiber, laser can be used as a source because in optical fiber, you can't pass the electrical energy. It will not accept electrical energy. Optical, as the name indicates, it accepts only the light energy as a source. So laser can be used as a source for the optical fiber. And this laser can also be used in some medical field for surgery and all. It can also be used in some defense sector. Okay. It can also be used in some NLO. NLO is nothing but non-linear optics. This some research in order to carry out some research, especially in the research field, these lasers can be used. These are the different applications of lasers. Okay. Basic principle of laser, as I told you, whenever a light falls on the matter, matter is nothing but anything which has a mass and occupies space. Whenever light falls on that matter, what happens? There will be, we could observe three different processes. What are those processes? Imagine this is a matter. Imagine for your reference, this is a matter. So matter is made up of what? Matter is made up of what are the subatomic particles will be there inside the matter? Sneha?
Sir,
So matter is made up of what? If you observe matter in a microscopic scale, what you can see? Simple question. Varun? Varun?
That is made up of tiny particles.
Very good. It is made up of particles, right? Again, yeah, Devendra, electron, protons. Excellent answer. Both of you, very good. Matter is made up of small particles. Again, if you increase your resolution of the microscope, and again, you take one particle, imagine this is matter, made up matter in a macroscopic scale. You cut this matter into powder and you can see particles, different particles. Again, what you do, you take one particle and keep inside the microscope. This is sample holder. This is your particle. You kept it. And if you observe here in a microscopic scale, if you observe using some whatever, some high resolution microscope, say like scanning electron microscope or transmission electron microscope, if you observe this particle, what you can see different atoms. Again, inside atom, there will be electron, proton. Again, atom is made up of what? There will be a nucleus, right, at the center. Inside nucleus, there will be again subatomic particles. These are the different orbits. Okay, there will be electron. In different orbit, how many electrons will be there? You can use 2n square formula. N indicates the orbit number. Suppose if we consider first orbit, 2 into 1 square is 2. There will be K shell. There will be 2 electron here. There will be 2 electrons. In the next shell, L shell, how many electrons will be there? 2 into 2 square. 2 to the 4, 4 to the 8. There will be 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Like that, there will be 8 electrons. So we can determine how many electrons will be there in different orbits. This is my nucleus. Inside nucleus again, what will be there? Yukta? Yuktashri. Yuktashri, are you there? Yeah. What will be there inside? Yeah, you are messaged. What will be there inside the nucleus? No, I'm asking. Yeah, one atom I've taken, that is nuclei. Inside nuclei, what will be there? What are the particles?
Sir, protons and neutrons, sir.
Very good. Dhanraj, very good. There will be, yeah, Yuktashri also answered. Very good. Both of you good. Again, inside the nucleus also, there will be proton and neutron. So can anybody tell me what is the charge of nucleus?
Sir, positive.
Zero.
No. It is not zero or not neutral. It is neutron has got no charge. Proton has got positive charge. So charge of the nucleus is positive. So as you say, suppose if I consider this is zero or neutral, electron will never stay here, isn't it? Suppose if I consider this, the polarity of this nucleus is neutral, electron will never stay here. Why electron is attached to this K shell? Because imagine, this is your K shell, this is nucleus, this is positive charge, this electron is negative charge. There is a electrostatic attraction between positive nucleus and to the negative electron. So electrons stay here. Suppose if I consider this is neutral, complete universe will never exist because the matter will never exist. Suppose if I consider this is neutral charge, because of positive charge it attracts, so it builds up mass to all the particles. Okay. As I told you, there will be proton and neutron inside the nucleus. So can anybody tell me what will be there still? If I dig into proton and neutron, what will be there inside proton? Can anybody? I think in the 2012, two physicists, they got Nobel Prize for this invention, for this discovery. Let me say discovery. If you know answer, you can tell me, or else it's okay. Dhanraj?
Sir, 3 quarks.
Sir,
Very good. So see, if you know the answer, tell me directly. Very good. There will be 3 quarks inside the proton and 3 quarks inside the neutron. That is also subatomic particle. Quarks will be there inside proton as well as neutron. When 2 quarks travel at the speed of light, not exactly equal to speed of light, near to speed of light. If these 2 quarks send at 99.9 to the speed of light, and when they get collided, there is a production of something. What we call that something? It is also called God particle. Anybody? It is also called God particle. It was sent inside the LHC, Large Hadron Collider. This is one of the accelerator. Accelerator is nothing but what? It is a device which increases the speed. That is called accelerator. This LHC is also Large Hadron Collider. This is also one of the accelerator. It is around 24 kilometer. The diameter of this will be 24 kilometer. Like this, it goes like this. Okay, accelerator. So inside this accelerator, one quark along this direction, another quark and along this direction, they sent at almost equal to 99.9 to the speed of light. They sent these two quarks, they get collided some area. During that collision, there is a production of something which is called Higgs boson, which is called Higgs boson. See, you should not stick on to the syllabus. You should always, explore yourself to the new invention and discoveries. Okay. Yeah. Let me come back. As for this invention, they got two physicists. They got Nobel Prize in the year of 2012 for the discovery of Higgs boson. So that is also called God particle. That God particle is the reason for all the substances or particles which occupies mass. Okay. Yeah. This is where I was. This is my matter. I'll pass some energy or electromagnetic wave to this matter. The moment I pass electromagnetic wave to the matter, we can observe three processes. One is called induced absorption, other one is called spontaneous emission, and the third one is stimulated emission. What is this induced absorption? It is just absorption. Next one is spontaneous emission. Spontaneous is nothing but without any external energy by itself. The process happens naturally by itself, called spontaneous. Next we have stimulated. This stimulated will not happen naturally. As the name indicates, you have to stimulate. You have to stimulate by using some external energy. Okay. Look at here. This is absorption. These two are emission. This is according to conservation of energy. This absorption should be equal to emission, right? This is absorption process. These two are emission process. From this, induced absorption will not get laser. From spontaneous emission will not get laser. We get laser only due to the process of stimulated emission. Again, now to understand what is stimulated emission, we need to know something called what is induced, what is spontaneous. Without having the knowledge of these two, we can't understand what is stimulated emission. Okay, so we'll go one by one. Whenever the electromagnetic radiation falls on the matter, you could observe three different processes. One is induced absorption, second one is spontaneous emission, and last one is stimulated emission. Induced absorption and spontaneous emission will not yield the laser beam. Only stimulated emission will give us the laser beam. So before that, we'll understand what is induced absorption, what is spontaneous, and what is stimulated. Okay, I'll be asking the question now. So understand carefully. Before we get into these three concepts, let us understand how the matter is made up of. Okay, sample energy level diagram. If you can take up any matter and if you observe in a microscopic scale with high resolution microscope, you could observe this is atomic scale. The structure of an atom. This is nucleus. These are the different orbits. Electrons will be revolving around the nucleus with upspin as well as downspin. One is plus of and the other one is minus of. They rotate. Okay. There will be different states. Let us consider this is my ground state. This is excited state. This is my ground state. This is my excited state. Okay. Ground state, let me call 1 excited state. From now onwards, I'll be using 1 to represent ground state, 2 to represent excited state. I'll not write completely ground state or excited state. Okay. Let me call energy of the ground state as E1, energy of the excited state as E2. Okay. Let us consider atoms or molecules occupy the ground state itself. So no atoms will stay in the excited state. Remember, no atom will stay in the excited state. Naturally, all the atoms always occupy the ground state. All the atoms always occupy the ground state. Okay. Let me call number of atoms in the ground state as N1. Whenever I represent N1, that means that is the number of atoms in the ground state. Let me call number of atoms in the excited state as N2. N1 is the number of atoms in the ground state, N2 is the number of atoms in the excited state. Difference between E2 and E1, energy between excited state and to the ground state, that the difference is called delta E, or let me represent H mu. Okay, I repeat again. This is very important. Okay, this is atomic scale. Let us suppose if I look at the matter in a high resolution with a high resolution microscope in an atomic scale, there will be excited state and there will be ground state. Okay, actually, let me tell you, practically this excited state or ground state will not exist. It is not exist. It is completely a theoretical concept. Completely a theoretical concept. Imagine you have one atom. Remember, you have one atom. In that atom, there will be K shell, L shell, M shell, K element. It goes like this. You have, imagine, in your left hand, you have one atom. It has got ground state, excited state, and all. K shell, L shell, M shell. In the right hand also, you have another atom. It has got K shell, L shell, M shell like that. So you have some n number of atoms. You combine all together. You combine and squeeze all together. What is the lowest energy level you get? No, that lowest energy level is called ground state. What is the next excited state? Next higher energy level you will get, that is the excited state. Actually, this ground state, excited state, theoretical concept. It is completely a theoretical concept. So let me call this is ground state as 1, excited state as 2. E1 is the number of energy level, energy of ground state. E2 is the energy of excited state. The number of atoms in the ground state represented by N1, number of atoms in the excited state represented by N2. You might ask me, nobody asked me the doubt. Sir, always you said always atoms stay in the ground state. Then how come atoms in the excited state? So I was expecting this doubt. So when do you expect atoms in the excited state? When you pass some energy. When you pass some energy, this atom which is staying in the ground state absorbs this energy, then it gets elevated. It gets excited to the excited state. And it stays up to some time. Always it has to come back to ground state by naturally. But it stays for a very fraction of time, say for example 10 power minus 8 second. It stays only up to 10 power minus 8 seconds, 0.0000001 second. It stays only for a fraction of time. After 10 power minus 8 second, it loses all the energy. Again, it will come back. Because initially it has heated some energy, right? It has absorbed some energy. It's elevated. It stays up to 10 power minus 8 second. After that, it has to come back to ground state. While coming back to ground state, it has to emit some energy because energy neither be created nor be destroyed, right? So it has absorbed some energy, so it liberates some energy. It is natural process. The difference between these two energies is called delta E. Let us now, we have understood this is just a sample energy level diagram. Let's look into what is induced absorption now. Okay. Induced absorption is nothing but, as I told you, this is ground state. I have already explained. This is my excited state. So atom in the ground state. Let us consider this is my atom. This is my atom which is staying in the ground state. First process I'm talking about the induced absorption. This is first one. Induced absorption. This is my ground state. This is my excited state. Atom in the ground state. Always atom has to stay in the ground state itself. Now you have to send this atom to the excited state. What you have to do? You have to give some energy, right? You should give some energy. Without giving any energy, it will not absorb anything. It will not get elevated. So you pass some energy now. You are given some photon. This atom will not eat. This atom is staying in the ground state. Always the atom will, is hungry to eat something. So it has absorbed. See, the moment you give energy, this atom absorbs this photon. The moment it absorbs some photon, the moment it gets some energy, it will not stay in the ground state. So it is heating something. Now it gets elevated. Where is the atom now? Now it is in the excited state. So this is called induced absorption. This is called induced absorption. I'll just repeat again. This is ground state. This is excited state. Atom always stay in the ground state. So you have to send this atom to the excited state. This is excited state. So what you do, you give some energy. The moment you give some energy, the energy must be equivalent to difference of these two energy. It has got some E1 in E2. It has got some E1. When E2 minus E1, if it is comparable to delta E, or if it is greater than delta E, then only this atom absorb this photon. If the photon what you are passing, if it is less than delta E, then it will not absorb, it will just go out like this. It will not, atom will not absorb this energy. Remember this. Now, you are given some sufficient amount of energy. This atom absorbs this incident photon and gets elevated. This is called induced absorption. Okay. Again, this will not give you laser, but this process is important. Exactly, understand. Now, can anybody tell me this induced absorption? See, I repeat again. Atom is here. It is absorbing and it goes to the next excited state. This induced absorption depends on what are the parameters. This induced absorption is proportional to what? Chikana?
Distance, sir.
Distance. So, okay. Can anybody? Ananya?
Energy supplied.
Energy.
Very good. Very good. Energy you have supplied to elevate that atom. It depends on that. Only that? Only energy?
Sir, frequency.
Yeah, energy is nothing but frequency equal to h mu. Suppose if you say energy, obviously frequency E equal to h mu. E is directly proportional to mu. Anybody else? Suppose if there is one atom, how many atom gets elevated? Open your mouth now. Nane kelbaka. Dhanraj?
Yes, sir.
If there is one atom in the ground state, how many atom gets elevated to the excited state?
Sir, one only, sir.
One only. Correct. If there are two atoms,
Sir, it depends on number of electrons.
yeah, atom or electron, whatever I consider. So I suppose if I say atom, that means I'm talking indirectly electron only. Yeah, very good answer. Say for example, this is excited state, this is ground state. Imagine if there is one atom, you have given some energy, one atom will absorb, one atom gets elevated, right? If there are two atoms, if there are some four atoms and you have given more amount of energy, four atoms gets elevated. This induced absorption solely depends on two parameters. One is the whatever the incident energy you are passing and how many number of atoms are there in the ground state. Will you all agree with this? This
Yes,
rate
sir.
of okay. This rate of absorption is directly proportional to N1. What does N1 indicates?
Number of atoms.
Number of electrons.
Yeah, very good. Yeah, correct. Atom. See, generally we say atom. Actually, it is electron. Okay. Yeah. N1 number of atoms or electrons in the ground state. E mu is nothing but it is the incident energy. I should remove this proportionality constant. This is a proportionality constant actually, like this. Okay. I should remove this. What is the procedure? I should add some constant, right? Let me add B. Let me add B is one of the constant. 1, 2. B1, 2 I have written. What is the meaning of 1, 2? Atom has gone from which state to which state?
Ground state to excited
Sir,
state.
first to second.
Yeah, very good. Ground state to excite are first to second. That means 1 indicates ground state, 2 indicates excited state. That is the meaning of this. Suppose if I write B1, 2, atom gets elevated from state 1 to state 2. That is the meaning of this equation is very, very, very important. Remember this because in order to derive, this is B, A and B. In next equation, I'll be calling A. Here I'll call B. A, B are called Einstein A and B coefficients. This is Einstein B coefficient. If I call A, that is called Einstein A coefficient. Okay. Next, now what you do? As I told you, atom gets elevated. Atom in the excited state, it stays up to 10 power minus 8 second only. It stays up to 10 power minus 8 second. Now what you do? Next process. Atom in the excited state. Suppose if I say atom is here, that means induced absorption process already occurred. If I say atom in the excited state, no atom will be in the excited state. Let me tell you. Suppose if I say the atom in the excited state, it has already undergone induced absorption. And whatever the process occurs, that is spontaneous emission, that process occurs within 10 power minus 8 seconds. Okay. Now, atom in the excited state, that means the first case is this. Atom was here, you given photon, atom is here. This is first case. This is my second case. Atom in the excited state. Now it stays up to 10 power minus 8 second by naturally, spontaneously, without any external energy, automatically. I'm using different words: spontaneously, naturally, automatically, without using any external energy. By itself, it will come to ground state. By itself, it will come to ground state. But simply it will not come because initially it has absorbed energy, right? It has absorbed energy. That energy gets liberated. That energy gets liberated. This is called spontaneous emission. But what happens? This beam, this whatever the light it emits, no, this is not a coherent source. Not coherent. This is not a coherent source. So this beam of light cannot be considered as laser beam. This beam of light cannot be considered as laser beam. Okay, because it is not coherent. That is not in phase also. This is not coherent, not in phase also. That is the reason why it cannot be considered as a laser beam. It is not normally a polychromatic light. Now, can anybody tell me? It depends on this process. Depends on what parameter? This
Number of atoms.
very good. It depends on only one parameter. Very good. What's your name?
Ronit.
Puneet. Very good. It depends on only one parameter because you are not passing in energy. You are not passing in energy. No. By itself, it is coming to the ground state. It depends on, suppose if there is one atom will come to the ground state. If there are three atoms will come to the ground state. Depends on number of atoms in the excited state. Directly proportional to N2. That means N2 is nothing but number of atoms in the excited state. So I should remove this proportionality constant. So I should add some constant value. Let me add A. Why I have written 2 to 1? Because atom has come from 2 to 1 excited state to the ground state. So A to 1, A to 1. Because to remove this proportionality constant, I have added a constant called A. 2 1 indicates atom has come from excited state to the ground state. N2 have written as it is. That means number of atoms in the excited state. Okay. Again, this is not a laser beam because it is not coherent. Coming to next process, stimulated. Now we have understood what is induced absorption, spontaneous emission, and the last one is stimulated emission. What is the meaning of stimulation? You are, motivating. You are doing something. You are disturbing. Stimulated is something called disturbing, right? So again, I mentioned atom here. That means the first process got over. Atom was in the ground state. You are given some energy, h mu. This atom has absorbed this energy, gets elevated. It stays up to 10 power minus 8 second. So this is first case. And this is your second case. Atom was here. Within 10 power minus 8 second, you have to do something. You have to stimulate. Now what I do? Atom was in the excited state. Now atom is here. You pass some external energy now. You pass some external energy. I told you already, you have to pass appropriate energy. By naturally, you might ask me, sir, atom in the excited state. No, atom was here. The moment you pass energy, what happens? This atom may absorb this and it may go to the third excited state, right? Sorry, second excited. This is ground state, first excited, second excited. Or ground energy, first energy level, second energy level. It may go to the next energy level. So what you have to do, you have to pass some appropriate amount of energy such that this energy should stimulate this atom, should just disturb that atom. This is called stimulated emission. I repeat again, atom in the excited state, it stays up to 10 power minus 8 second. Within that 10 power minus 8 second, you stimulate this atom using some external energy. Due to that stimulation, atom will come to the ground state. So initially it has absorbed some energy, right? Because in order to elevate, you have given some energy, right? Due to that energy only, it has gone to the excited state. It emits two photons. One is initially it has absorbed, right? That is one photon. And this, the atom which you have passed to stimulate this atom, that also comes out. This one H mu, this is another H mu. So how many atoms total? So how many photons? There are two photons. So these two photons will be coherent and same amplitude and wavelength are same wavelength. What is the meaning of same wavelength? What does it indicate? Suppose if a light having a constant wavelength means, what is the meaning of this?
Sir, color, sir.
Yes, color. Because
Intensity will be high.
yes, intensity will be high. Suppose if a light is made up of single wavelength, means it is a monochromatic. It is made up of single color. Suppose if I consider red color, red laser, it is almost 650 nanometer. Similarly, if you consider green color, that may be having some constant wavelength. If it is yellow, that might be having same color. It is solely depends on the wavelength. If it is a constant wavelength, that means it is monochromatic. Again, you might ask me, sir, because suppose if I consider this is excited state, this is ground state. Suppose if I need red laser, I should make wavelength to be 650, right? How do you make this 650? Depends on the energy gap. This is excited state, ground state. It means this is conduction band, this is valence band, right? So difference between conduction band and valence band is called what? Energy gap, right? This energy gap should be
Energy gap.
varied. Yes, very good, very good. This energy gap should be varied in order to vary the color of a laser. To vary the color of a laser beam. Suppose if it is semiconductor laser, the energy gap will be almost equal to some 1.4 electron volts. So in our lab, I'm talking about in our lab. Again, semiconductor laser also depends on different semiconductor. We can vary the energy gap. Depending upon the energy gap, I can have different color of laser beam. That is the principle how they prepare different colors of laser beams. Okay. Actually, this is the principle of laser stimulated emission. So within 10 power minus 8 second, what you have to do, you have to within 10 power minus 8 second, atom will be in the excited state. Within it stays only up to 10 power minus 8 second. Within 10 power minus 8 second, you pass some extra energy in order to disturb this and in order to stimulate this. Due to the stimulated photon process, the atom come to the ground state. When it comes to the ground state, it emits two photons. Those two photons will be coherent, monochromatic, and will be having same amplitude. These two photons are called laser beams. Again, can anybody tell me it depends on what parameters?
Required amount of energy
Very good. Required amount of energy.
and the electrons.
Very good. It depends on two processes. Number of atoms. Very good. It depends on two parameters. One is how much amount of energy you pass in order to stimulate. That is one. And how many atoms will be there or how many electrons will be there in the excited state. It depends on two parameters. So proportional to N2 and mu. That means number of atoms in the excited state and the energy, given energy. I should remove this. Let me add B again. Atom has come from 2 to 1, right? Excited state to the ground state. So B to 1, N to mu. So now I can say that absorption will be equal to emission, right? According to conservation of energy, absorption will be equal to emission. Absorption we have only one, that is induced absorption will be equal to spontaneous emission plus stimulated emission. Spontaneous emission plus stimulated emission using conservation of energy. Using this equation, we substitute absorption, we have this equation. Yeah, absorption, we have this equation. Spontaneous, we have this equation. Stimulated, we have this equation. Using these three equations, we substitute all these three here and we do some modification, some mathematical operations. Then we determine something called energy density, Einstein energy density equation. What does this Einstein energy density equation says? Suppose if there are only two energy level, we can't produce a laser. And also at thermal equilibrium also we can't produce a laser. You don't understand now. If I tell you that, you don't understand. We have to understand other things also. What is the condition of laser and all. Yeah, you just understand what are the three different processes: induced absorption, spontaneous emission, and stimulated emission. And on what parameter it depends, and what is the principle of laser. Okay, stimulated emission is the principle of laser. Okay, this is absorption. Atom was in the ground state, you are given energy, it goes. That's it. Spontaneous, atom in the excited state, it will come to the ground state. See here, it is going in other direction, right? It is not going in a proper direction, it is going to different direction, so it is not monochromatic, so it is not coherent. Last one, stimulated emission, you are given one photon but there are two photons. These two are coherent, monochromatic. This is a laser beam. Okay, rate of induced absorption equal to, according to thermal equilibrium and according to conservation of energy, induced absorption equal to rate of spontaneous emission plus stimulated emission.